Are we recording? Yep. Okay, cool. Alright, so it's been a while since I've made any YouTube videos, but I figured, well, might as well make this into a tutorial. So, in the last blog post that I did on C# tutorials, I said I was gonna do Windows Forms programs, and writing that as a tutorial is so overly complicated to try and write. So rather than writing out a tutorial on how to make a Windows Form program, we're just gonna do it in a video. And I really wish Visual Studio didn't take so long to load up templates, but I've got like 30 languages installed into one little IDE, so that's about as much as it can take. So you're going to want to go to New Project, and then head over to C# and go Windows Forms Application. We'll name this Windows Forms Application, Windows Forms Program, WFA. Just Windows Forms Application Math Test Tutorial. That's a good name. So if you've been keeping up with all my little tutorials, you've hopefully learned about the different statements by now. You've learned how to instantiate a new class object, like right here, and how to set up a DLL and everything like that. So if you already have your DLL made, you're good to go. But if not, I'll show you how to make a library within your solution, so you don't have to go and browse around for a file that you can't find when it's just sitting right there looking for you. So we'll give this a second here to create our project. And sometimes it takes a while because it's gotta pull up all the references of Windows Forms and whatnot. But it's almost no different than making something like this, you know. It's just a matter of drawing things out how you want it to look, and that's pretty much it. So over here on the left side, you have your toolbox with all of your .NET components. You have your main form right here. You can see over here, this is under system.windows.forms, and then obviously it's a form, so that's what it's going to be called. You have all your components here, and then, on the right side here, you have all of your properties for whatever object you're clicking on. So essentially, Visual Studio just instantiates new versions of each of these objects from their specific DLL automatically for us, and then gives them whatever properties we choose. And every form, the text property just changes what it says at the top. So we'll name this calculator tutorial, and then we'll hit show icon false just because we don't want it to look super ugly. And we'll say fix single, and then because we don't want people to maximize it, I'll explain why later, we'll set maximize box to false. Alright, so that looks pretty nice. So we have our form here, everything looks good, and we don't really need to mess with anything else. So we're going to need one label, and just copy and paste, 2 labels, 3 labels. These are, they're exactly what they say. It's pretty self-explanatory. You know, a text box is to put text into, a label is to display something, and then we're also going to need one button. And then you can, if you have trouble keeping track of your different labels, we'll name this label num1. I'll name this label num2. We don't really need to give the button a special name, and we'll name this label answer. That's good. And just like with the form, for a label, your text property changes what's currently being displayed. So we'll name this first number, have this one be second number. Now there's different ways to align this property, and also when you click on an object, you can see you usually have the anchor points. Oh, that's funky. Careful when you're dragging you along, because sometimes it just totally, I guess, dies out on you. And we'll just align these to the edges, just for sake. If you hold Control, it lets you see the grid lines and align things easier. If you hold Control and hit the arrow keys, things will automatically align based on what arrow key you push. And we'll just let this be right here, and that's good enough. Alright, that's fine. And we'll have the button say calculate. And just to make things look nicer, let's make this not display any text right now. We'll make it not auto size based on... Auto size just means size of the label based on whatever text is currently being displayed. We'll change the background color to white, and we'll give it a nice little border. We'll say border style fixed single. Oh, not fixed 3D, that looks disgusting. And we'll say text align. Middle center is what I usually like to use for my outputs. And we'll resize that, take up a nice bit of space, and that's a pretty good simple form. And as you can see over here, this is where all of your events get taken care of. So your events are usually auto-generated. So if you were to double-click into one of these, it would auto-generate a method for whatever one of these events, I guess, whatever events you choose to program for. So if I chose key down event, I could have something happen anytime I pushed down on a key, or anytime I released it, or anytime I just push and release a key, or just release it, you know, so on and so forth. Load is what happens when the form loads up. Like, it's essentially what our constructor does when we're first creating an object. You know, it sets everything up for us. So anything you want to happen before the program starts, you'd say, you can just... The easiest way to get your events is to double click onto them, and so now it'll start generating our event for us. So you don't have to change the private void form load. You can leave object sender, and then the event args is whatever argument you're giving it. So there's event arguments, and then there's key event arguments, which are anytime you press a key or anything. There's mouse event arguments for if you click a certain what would you call it? If you click a certain click button on the mouse, something, you know what I mean. But what we're worried about is our calculate button. So we'll click into that, and now we have, whenever you click on the button, it's gonna run our calculate method. So we don't need to make a new method just to calculate it, but just for tutorial's sake, why not? So we'll say void calculate, and we're not going to give it any arguments. So now, if you haven't already made your DLL, you can just click into the solution bit right here, give it a second to load, and then go add new project, and then hit class library. That's what we want. So we'll name this math library. And you can write a DLL for your solution in any language that you want that's available for Visual Studio. You can make a DLL in F# and use it with C#, or in Visual Basic, or C++, or C, or anything like that. Any DLL works between any language that derives from C. So we have our new DLL here. We'll name it math class, and so we're gonna have 4 methods. So we'll say public, almost a public void. So we'll say public double add, not int, but we want doubles, double A, double B, return A plus B, public double subtract, double A, double b, return a minus b, public double multiply, double a, double b, return a times b, and then double, whoops, public double divide, double a, double b. And these are all just examples. You can make whatever method you want, or if you're really lazy, you can just go back over to here and literally just copy and paste these methods, or this entire thing. But you know, you do whatever you want. And so you go up to here, hit build, and that'll compile our DLL file for us. And then we'll give that a second to complete. And so while that's working, we're going to go back over to here. We're going to go to, oh, we can't do it just yet. Okay, so we'll go back over to our main form. We'll click add reference. Okay, that's better. Just had to give it a minute. Okay, so we'll go to add reference, and if you go to project, and then solution, check math library, hit OK. And so whatever you named your class right here, so we named ours math class, you just added a reference for your math library, and that's our namespace. So we'll go back into here. So in our calculate method, we're going to say var, we'll name it math x, just whatever, equals new math class, or math library. Wait a minute, that's not right. Hold on. Using math library, that's better. This way you don't have to say math library dot math class. So we'll say math class. And so now we've instantiated our new math class object. So we have all of the methods from our math library now in here. Now, cool thing about C# is it's strictly and dynamically typed. So usually in other object-oriented languages like, I guess, sort of Visual Basic, mostly Java. In Java, you know, and I usually do this just as a like for sure thing, just for readability. You would say math class math x y equals new math class, and then it's just annoying having to retype it out. But pretty much just like with JavaScript, you can just say var x equals new int 5. Well, that's not how you do that, but you'd say var x equals 5, and you'd say console.write line x, and it just writes 5. But C# is nice because it's strongly typed, meaning, you know, a bool can only be true or false, rather than in the language like C++, a bool can be true or false, or 0 or 1, or anything like that. So it's strictly typed, but it's also safe typed, which is a bit hard to explain for those who are unfamiliar with those terms, but you know, you don't need to worry too much about what that means currently. So now that we have that, we'll say double num1 and double num2. So just like in our console applications, right here, any numbers we go to input. Well, this is more so for one of our older tutorials. You know, if you were taking an integer from a console application, you'd have to say console, or you'd have to say convert.toInt32 console.readline, you know. And why do that when you can just say convert.toDouble, because that's what we're converting it to. So a text box has a text property just like everything else. So if I were to type in random text there, then that's the value of the text box at the moment. But everything in a text box is in string format because, you know, you have to be able to type in numbers and letters and special characters and so on and so forth. So we're going to have to convert a string to a double, and we can get the value of our text box by saying textbox1.text, just like that. So that'll give us our first number, and then convert, I don't like that extra space, convert.toDouble text box 2.text. So we have our two numbers that we input, and we'll say double sum, and then double difference, good old math vocabulary, double product, and double quotient. That's not how you spell double, and I'm not sure if that's how you spell quotient. It's been a long time since I've had to do math vocabulary. So sum will say mathx.add num1 num2, and so our sum will be, the result of calling the add method. We'll say mathx.subtract num1 num2, mathx.multiply num1 num2, and then mathx.divide num1 num2. Now there's easier ways to do this, like if you were to make a static method within your class, you would just say add, subtract, multiply, divide. You wouldn't have to instantiate a new object of a class library, but just because that's what we're using, we're just going to leave it like that. And so all of our stuff is going to be displayed here. So we'll say label answer.text equals, now here's a cool way to do this. So if you say string.format, and this is the easiest way to pass in a string just by calling argument. I'm not sure what the formal name of this, but if you just pass in your numbers as arguments and just leave your string as one big string, you don't have to say product plus sum plus name, you know what I mean? It's just easier to do it this way. So if we say sum is our first argument, and then difference is our second argument, our product is our third argument, and our quotient is our fourth argument. Now, just like any other indexes always start at 0, and always, they go on until you hit the number of items that you've reached. So our first argument will be sum, difference, product, and then quotient, just like that. And we can leave everything just the way it is. And if you want to format your quotient or something to 2 decimal places, you can say %.2f before calling your little 3 in brackets. There's various different ways to format numbers, but we're just going to leave it like this for now, and we'll just give it any old number. So we'll give it some whole numbers. Oh, I forgot we did that in a different method. So if you actually wanted to do something in your button click event, you're gonna want to call your calculate method and not forget to do that like I did. So let it rebuild our program really quick, and we'll say random numbers. We have high CPU usage detected. That's kind of cool. And then bam, we have, oh, I typed in the same exact number. Okay, so our sum, our difference, our product, and our quotient. And it works with decimals as well. You can call them out to any decimal places because we're using a double rather than a float, or a decimal based number, or a short or anything like that. Except there's one other problem. So if we go into our program and we give it, 235, what happens if we don't put anything in? Or what happens if we put in, a string? It's gonna give us an error right here. So if we don't put in anything at all, that's when it's gonna give us some problems. So what we're gonna do, which you should have learned already, we're gonna make a try catch statement. So we'll say try catch, and then just fix this up because I hate the way that looks. So if there's an error, we'll say messagebox.show, you must put in a valid number for both text boxes. And that looks good. That's usually how I write my catch statements. I always put them in one line if possible. It just makes it look nicer. How we doing? One or more errors occurred. It doesn't matter. Anyways, so try to parse the numbers. If there's an error, show the message box. So we'll give that number. Oh, didn't put a number for both ones. So what if we put in a bunch of letters? Oh, still doesn't work. What if we put in... Oh, it works again. So that's basically it. That's how you, that's the easiest way to utilize a DLL file within another program. You know, usually you don't, or at least I don't usually make my DLLs within the same exact solution that I'm making a Windows Form program. And the only reason you'd really need to do that is if you were making like an enterprise style program that was meant to do like the same computation like thousands and thousands of times over and log the results to a text file. I would do that. I would make my form up in C# just to lay things out nicely, and then I would make my DLL in F# just to get all the math out of the way and whatnot. And that's what I've been doing as of recently for more complex things. But so we're gonna leave it like this for now. I'd say that's pretty good, and not too sure on what we're gonna do for the next tutorial, but we'll leave this here for now, and then I'll think of what to do next, because there's much more complex things I want to get into outside of Windows Forms programs, because it's literally just drag and drop and playing around with properties that, you know, that it does exactly what it says. You know, whatever you want, you can change in here. You can change all your colors. Your forecolor changes the color of your text, like right here. If I were to change this forecolor, would change the text to, like if I wanted that to be red, I could make that red. I could change, whoops, don't want to make that event. If I wanted to make this bold, I would change that in there, you know. If I want to change the button to flat style, we can make that flat instead of the regular and give that a cool little background, like purple. Nah, that's too dark. What about lighter purple? That's not bad. But if you want, you know, just play around with Visual Studio, throw some things together, and play around with different things and whatnot. But we're gonna leave that at that, and we'll see you next time.